So if we go back to intermediate value theorem, recall from yesterday we had 3 pieces, yes? If I go back to which page? We had 3 pieces for intermediate value theorem. Has to be continuous. The endpoints cannot equal each other. And the value in question has to be between those 2 endpoints, right? So as we look at number 4, okay, use the intermediate value theorem to show that f of x has a 0 in the interval 0 to 1. Remember from yesterday, continuous. Is it continuous? X cubed plus 2x minus 1?
Yes.
That's polynomial, right? So I wrote as that point is that polynomials are continuous. That's a fact you can state on AP, okay? Then, if you recall from yesterday, we did this on the previous one, check the endpoints, right? Again, trying to be quick here. Endpoints, my interval was 0 to 1. So f of 0, you plug it in, you get -1. F of 1, you plug it in, you get 2. I correlated the fact that they're not equal to each other. It helps to point that out. Just, hey, I recognize this. And then, so it's continuous. My endpoints are not the same. What's it mean to have a 0? If it's a 0, it's a crosses through the x-axis, right? X-intercept. So that means it's going to be a, what do I want to say, x value, comma, 0. And so I wrote it as f of c equals 0. Well, does that fall in between -1 and 2? And it does. Okay, that y value of 0 falls between -1 and 2. So since f of 0 is basically less than the number in question, 0, f of 0 is less than 0, f of 1 is bigger than 0, then there exists a value such that f of c equals 0 on that interval 0 to 1. That's the fancy speak, right? That's your official AP talk. Okay, so you guys can go back through these slides if you need to get more information after I leave. Does that work? Just because I don't want to take too long here. Okay, 5. A car travels on a straight track. During the interval 0 to 60 seconds, the car's velocity v, measured in feet per second, is a continuous function. The table below shows selected values of the function. Calc loves tables, okay? So, and it gives a and b, but it's really just the same thing. For the intervals 0 to 60, must there be a time when v of t equals -5? Okay, what's the first thing we need to check? Is it continuous? You don't know that by just looking at the table. They give me random values. We don't know if it's continuous. They have to tell you. But what did they tell me up in the beginning of the problem? They said continuous, right? So we know continuous. Then you guys know enough to know that we're going to check the endpoints, right? So one endpoint was 0. V of 0 is going to be, according to your chart, -20. V of 60 is going to be 10 according to your chart. Notice they are not the same, right? And then, so what's that say? Must there be a time v of t equals -5? Does IVT guarantee a time? It does, or a velocity. Because -5, right, falls between a -20 and a +10. Okay, so IVT guarantees there's a value somewhere in that interval where v of t equals -5. Okay?
Is that just because it's continuous?
Right, because it's continuous. Because we have that condition that we know this is a continuous graph. If we were just looking at this chart, well, it falls into the pattern or into the groove, we don't know if it would actually hit that because those could just be points. We don't know if it's continuous until they tell us those words. Okay, so they will tell you that on the chart.
So the chart's like useless except for the 0 to 60.
It gives you the values. I mean, it gives you the values, which is what you need there, and then, but the stem tells you continuous. So always look for, we've got to have some way to know how is it continuous. Do we know it's continuous? Sometimes they'll be nice. It's just, there's your word, continuous. Polynomials are the other one we've talked about, right? continuous. Okay. Multiple choice. Let G be a continuous. They're telling me right off the bat, right? It's a chart again. They're telling me it's continuous function. Selected values of g of x are given in the table. For which value of k will the equation g of x equals 3/4 have at least two solutions on the closed interval 2 to 8? Okay, so this one, having seen it written out, might not be the best one for this. We want to know what k value is going to guarantee that there's two solutions at 3/4. Remember, g of x equals 3/4, that's y equals 3/4, horizontal line, right? At least that's the vision that my brain does. So we want between the point 3,4, here's my kind of visual, and the point 5,5. I need this graph, this continuous graph, to cross 3/4 twice. What's that going to mean has to happen at 4k? That's going to have to go somewhere below 3/4. Does that logic make sense there? That if we need it to cross 3/4 twice, it's going to have to go below 3/4 so it can go down there and come back up, right? So with that in mind, as you look at your multiple choice options, what's below 3/4? One's not. 3/4 would just cross it once. 3/2 is above 9/16. Yeah, because what, 12/16 would be 3/4? So 9/16 would take you slightly below. A visual of a graph on that one, a visual of a graph on this one. They give us a piecewise function, f of x. Now it asks us first to find f of 5 and f of 10. Then it asks us if IVT guarantees a y value on the interval from 5 to 10 such that it is between f of 5 and f of 10. So it asks us to find f of 5 and f of 10. Are you guys comfortable with that? F of 5, it says to use the top piece of the piecewise function, right? When x equals 5, plug the 5 in, you get 4. F of 10, well, now we're using the piece that is between 5 to 10, where it equals 10, and that just tells me that it is 6. The y value is 6 there. So those are my two endpoints of this interval. What haven't we been told here? We haven't been told continuous, right? Now, if we look at the top piece here, individually these are continuous, right? X minus 3 squared. X minus 3 squared would be a parabola. 6 is just a line, yes? So those individually are continuous, but what do we have to check? We did this a couple lessons ago. Do they meet, right? And so what happens when you look at this? When x is 5, we came up with that it's 4. So that's the point 5, 4. Over here, on the interval from 5 to 10, f of x equals 6. Well, that's like y equals 6, which is a horizontal line. So here's my graph. There's y equals 6. There's the removed point. Does that meet the continuity definition? And it doesn't quite meet the continuity definition, does it? If we look, it would have to be continuous on the interval from 5 to 10, including the endpoints. The endpoint at 5 is the problem, okay? So the justification here I used, the limit from the right approaches 6 is the right of 5, but at 5, we already know that f of 5 is 4. So right here, basically, 4 and 6 aren't the same. So this is 1. We don't get this very often, do we? IVT does not guarantee it. It doesn't even apply. I can't use this definition because continuity is not there. Okay? One more real quick. Nope. Oh, I did delete a slide. Oh. Dang it. Man, that was a good one, too. Shoot. I thought I accidentally deleted a slide when I was doing something earlier, but I couldn't figure out what slide it was. Man, oh man. Okay. So, on this last one here, you guys have it in front of you, yes?
Mm-hmm.
Okay. F and G are continuous for all real numbers. So right there, what are we told? Continuous. The table below gives values of the functions at selected values of x. The function h of x is given, and so h of x is defined there to be that g of f of x plus 2. Explain why there must be a value on the interval 1 to 6 such that h of w equals 0. So I'll just do some of this freehand. You can look at my notes later if you want to get more specific, but what's the first thing we've been checking? Continuous, right? And what I have written in my notes is that F and G, and I'm gonna shorthand this, right? F and G we're told are continuous. What are we actually talking about? We're actually talking not about F and G, but we're talking about
X and Y.
well, but that they go into H. Where does H come from? H is G of f of x, yes?
Mm-hmm.
And so the idea that if f and g are continuous, then h is also continuous. Does that make sense? And again, I'm shorthanding because, you know. What do we have to check next? Is it continuous? And then we've been checking the endpoints. So they ask about the interval of 1 to 6, so we've got to figure out h of 1 and h of 6. H of 1, well, h is defined to be g of f of x. So I'm going to say g of f of 1 plus 2. Okay, good review, guys. G of f of 1. How do we do composite functions here? G of, what's f of 1?
2.
You guys agree with her?
Mm-hmm.
Look at your table. F of 1 is 2. And then plus 2. What's g of 2?
-12.
And negative 12 plus 2?
-10.
Negative 10. So h of 1 is negative 10. H of 6, same thing, right? G of f of 6 plus 2. Start on the insides. F of 6 is 8. So now it becomes g of 8 plus 2. G of 8 is 28. Plus 2, which is 30. Okay, h of 1 is negative 10. H of 6 is 30. We found our endpoints and also realized that they are what? Not equal, right? So it's continuous. Endpoints are there not equal. Does IVT guarantee a point?
Yeah.
Yeah, because it said such that h of w equals 0. What do we notice about 0? It's between negative 10 and 30, yes? Okay, so for my final statement, I cited IVT, intermediate value theorem, so by IVT, there exists a value. Now, they didn't use C on this one, did they? They used W. So x equal W, where, and we're trying to say that h of W equals 0. And how can we say that? Because h of 1 is less than 0 is less than h of 6. And that's on our interval of 1 to 6. Okay? So. Okay, does that give you the brief rest of it? It really followed a lot of the same stuff, right? Where it's checking continuity, checking the endpoints, and is that the value in question in between the endpoints? Okay.